demonstrating about our verification tool, MoCHI. MoCHI is a software verification, software model checker for higher order functional programs. That is based on higher order model checking, predicate abstraction, and counterexample guided abstraction refinement. MoCHI takes an open program as an input and checks that the program assertions in the program never fail. And it outputs refinement intersection types if the program is safe. Otherwise, the program outputs a counterexample. Okay, I'll show you a demonstration of MoCHI. You can try it by here. Okay. This is a web interface of MoCHI, and consider this program. This program calculates the sum of integers up to n, and asserts that the sum is greater than n. MoCHI checks that the assertion never fails for any input. To verify this program, just click this button. Then the verification result is safe. And MoCHI outputs the refinement type of sum. This means sum takes x1 as an argument and outputs x2 that is greater than x1. Okay. It is easy. Okay, let's see more complex example. This function is a famous MoCHI 91 function. The definition is complex because it has Java recursion. But the behavior of this function is quite simple, because it always returns 91 when argument is less than or equal to 101. Okay, let's verify this program. And the result is safe. This means the assertion never fails for any n. And MoCHI outputs refinement intersection type for MoCHI 91 function. The type is a little bit redundant, but it includes this refinement type that we want. If an argument is less than or equal to 101, then the return value is always 91. Okay, this program and the previous program are safe ones. Okay, let's see unsafe program. Okay, when we write this program like this, then the verification result is changed to unsafe. And this means this is a counterexample of this program. This means that the program fails when an argument is 102. And this is corresponding error trace that the program calls main function with 102 and calculates them part and calls 91 function with 102 and calculates them part, and finally asserts that and it fails. Okay. MoCHI supports the optional features listed here. Base types, tuples, recursion, higher order functions, and exceptions and algebraic data types. That includes user-defined data types. And MoCHI checks the property, not only the assertions in the program never fail, but also the pattern matches in the program are exhaustive. and an uncluded exception does not occur. Okay, let's see the example of that that include higher order functions, adjective types, and exceptions. This program uses exceptions. Function fact returns the factorial if an argument is positive. Otherwise, it raises an exception not positive. In the main function, an exception is caught when n is not positive, only when n is not positive. And MoCHI checks that an uncaught exception does not occur. Okay, let's try this. Then the verification is successfully worked and it's safe. Current implementation does not act with the information about exceptions, so fact is just introducing it. And next, I'll show you the program that manipulates lists. This program calculates, this program makes first a list of integers and filters out empty lists. And finally, applies head functions to each element. MoCHI checks this application of head does not never fail. So let's try. Then the verification is yes, it's safe. And output refinement type. It is hard to read, but we can reduce this type to more readable type. Yes. Okay. And the last example is about user-defined data structures. This program defines arithmetic expressions that consist of constants of integers and additions. And the program defines evaluation of the expressions and generator and mapping function. The program first makes expression and replace constants with these absolute values by mapping function, and asserts that the evaluation of the expression is greater than 0. Okay, let's try this program. Yes, and the result is safe. Yes, we are. Okay, let's back to slide. Okay, I'll show you internal flow of MoCHI. MoCHI is based on verification framework presented at PLDI. It is for simply type 1 calculus with integers and recursion. Given an OKR program, then MoCHI translates the program into programs with only integers by encoding adjective types and exceptions as functions over integers. Once the program is translated to a program with integers, then we can use this method to verify the program. And the method of the LBI, the translated program is first abstracted to Boolean program using given predicates. And the abstracted program is verified by higher order model checking. It is sound and complete. So if the abstracted program is safe, then the original program is also safe. Otherwise, the original program is in fact unsafe, or the abstraction is too coarse. So if the latter, we discover new predicates to refine abstraction. And then we repeat these steps until we find whether we find whether the program is safe or unsafe. Here is a comparison with rigid types, dependent ML, and HMC. Our verifier MoCHI is full automatic verifier, while rigid types and dependent ML ask users to provide predicates or refinement types. And as you can see, MoCHI can discover counter examples, while others not. And MoCHI can check that program has intersection types. That means the method is context-sensitive analysis. Okay, let me complete my talk. We have implemented MoCHI for a subset of all count, and we want to extend to support a larger subset of all counts that includes mutable references and modules. And more important, we want to extend to deal with more larger programs.